Again, welcome to Mathematics 164. That's pre-calculus. In this lectures, we're going to discuss about linear inequalities in two variables. Again, these lectures cover chapter 4 of our course textbook, section 1. So this is lecture 4-1, linear inequalities in two variables. So our main objective is to graph linear inequalities in two variables. Also to solve system of linear inequalities in two variables. So we start with the one linear inequalities in two variables. So here we say that if we have a graph or the graph of y less than x consists of all points in which y coordinate is less than the x coordinate based on the condition. Now, if we have a graph and the graph is y always greater than x, then it means that all the points in which y coordinate is greater than the x coordinate. So the graph of the region y less than x can be found by graphing the first thing y equal to x. So that is the step. If we want to graph inequality, first we have to graph the quality of it. So y less than x, we're going to first of all graph a straight line, which is y equal to x. But we make it as a dashed line because the given inequality does not include y equal to x. Now this line will separate the xy plane into two half planes. So we may have y less than x and also y greater than x. Then we can determine which half plane is the solution region by selecting as a test point any point not on the line. So for example, we can choose 2 and 0 as it can be any point. So again, that's the steps on solving this inequality with two variables, one in linear inequality with two variables. In this case, the variable is y and x. So this is the example. So the first thing we do again, we plot the line y equal to x. And that's the dotted line, which means our result can be upper or lower. Now we take a point 2 and 0 so we can see on the blue area. Then when we test 2 and 0, our answer was correct. So that will be our solution, the blue region. So now let's again going to use an example soon. So here we say that if the coordinates of the test point do not satisfy the inequality, then the other half is the solution. Again, this is one linear inequality in two variables. Later, we are going to have system of linear equation or system of linear inequality. So for example, we say we are choosing 0 and 4 as our test point. Its coordinate do not satisfy y is less than x. So that half plane does not contain 0 and 4. Now let's use an example here. So here they say we should graph inequality 4x minus 2y less than or equal to 6. So the first thing we can do is to graph it 4x minus 2y equal to 6, then make it as a dotted line. Then we can take any points either above the line or below the line to check the condition. Now, if you take any point and you check the condition is true, based on here, we say 4x minus 2y is less than or equal to 6. If it's true, then that area is our solution. If it's false, then the other area will be our solution. So let's go through the steps. So the first thing we have here is 4x minus 2y less than or equal to 6. So we are going to graph 4x minus 2y equal to 6. And 4x minus 2y equal to 6, we can multiply everything by 2. So it's the same as writing y equal to 2x minus 3. Because when we divide all the terms here by 2, we get 2x minus y equal to 3. So y will give me 3, and then the 2x, 3 minus 2x. But remember, you have minus y. So you multiply the whole equation by -1. We are going to change 2s from negative to positive, and positive 3 we change to -3. Now with this, now we can plot our straight line. So that's what we did here. We get our straight line. Then when we plot our straight line, we can take any points. Here we decided to take 0, 0. So 0, 0 will be at the upper and to the left side. So when we take a 0, 0 and we plug in the value, again, it satisfied the condition. And so the condition was true. We see that its coordinates satisfy the condition. This is true, because it will be 0 greater than or equal to -3, which is true. So next we go to the system of linear equation. So with the system of linear equation, here we say if we have 2 or more inequalities, or we say 2 or more equations, then we can find system of linear equation. And here we can find a solution that satisfies all the inequality. We call the inequality a system of inequality. And the solution of the system can be found by finding the intersection of the solution set of all the inequalities. So the solution set of the system of inequalities can be found by graphing the inequalities on the same set of axes and noting their points of intersection. Now we're going to see an example which will help us more. So here we're going to graph the solution of the system here. 3s minus 2y greater than or equal to 4, s plus y minus 3 greater than 0. So the first thing we're going to, again, we're solving this problem using graph, so graphical solution. So we're going to plot the first line and the second line. So here we convert 3s minus 2y when we find the x and y intercept, because this is a linear. So if we get 2 points, we can just draw a straight line across it. So quicker way, find the x-intercept and the y-intercept. For example, the first one, when x is 0, y will be -2, because we're going to get -2y equal to 4, which will give me y equal to 4 divided by -2. So that will give me -2. Same thing, we find the x and y-intercept for s plus y equal to 3. If s is 0, y is 3. If y is 0, s is 3. So s is 3. So with these two, we can plot our straight line. So the dotted line is s plus y equal to 3. The thick line is 3s minus 2y equal to 4. So the next thing we're going to do is to take a point in any of the region. So here we say we use any point not on either line as a test point. As far as the point is not on the line, it's okay. We can take, we have 4 regions now, 1, 2, 3, 4 regions, 4 areas. So here we decided to take 0, 0, which means 0, 0 will fall around this region. So if we take 0, 0, we get 3s, we use 3s minus 2y greater than or equal to 4, or the x plus y minus 3 greater than 0. So here we can plug in the values and see if the condition is met. So if it's 0, 0, it means we're going to get is 0 greater than or equal to 4, or it's -3 greater than 0. So here we say that we use any point not on either line as a test. So let's use 0, 0. Note that the coordinate of 0, 0 do not satisfy either equation or both equations. So we need to go to next region. So this is 0. So this area, or we can use this. So we go to this region area, we can take any point. So let's say if we take a point here, it will be 4 and 1. So we can use 4 and 1 on any point. So here we say the solution region for each individual inequality is the half plane that does not contain the point 0, 0. So as we said earlier, since we have this area will be the solution. If it's not the solution, then the opposite area will surely be the solution. How do we determine it? Take any point in the plane. We took 0, 0, or any value you can take. So again, this is the system of linear equation. So now we're going to plot the two lines. Normally, if it's system of equation, the intersection of the two lines will give us the solution, x and y value. So here we say we use any point not on either line as a test point. So we use the 0, 0, but the 0, 0 didn't satisfy the condition. So it has the solution region for each individual inequality is half plane that does not contain the point 0, 0. So this is what we get. 4.4b indicate the half plane solution for each inequality with arrows pointing from the line into the desired half plane away from the test point. So the point that satisfies both of these inequalities lies in the intersection of the two individual solution region. So this is, so if we take any point at the top here, we most likely won't get the result. But 2 and 1, this gives us the result. So the solution region is the graph of the solution of this system of inequality. So now solving this problem, as we said, here we have two equations now. So we're going to plot the two lines. Then based on what we are looking for, in this case, the region area that satisfies the condition. So we take a point in any of the region. If it couldn't satisfy the condition from the question, then we go to another different region. So we take 2 and 1, where the two regions form corner can be found by solving the equation. So next is the CDF appearances have assembled plants in Atlanta and Fort Worth, where the company produced variety of kitchen appliances, 12-cup coffee maker and cappuccino machines. So at the Atlanta plant, 160 of the coffee makers and 200 of the cappuccino machines can be assembled each hour. And also at Fort Worth plant, 800 of the coffee makers and 200 of the cappuccino machines can be assembled each hour. Now the question says we should write a system of inequality that describes this assembled plant constraints and graph the solution region for the system. So this is what we get from the question. We saw the coffee maker in Atlanta spend 160 hours, more than 60 per hour. Cappuccino machine 200 hours per hour. We have Fort Hood and also the needed values. This is our constraint needed values. So this table and the fact that both x and y must be non-negative give the following constraints. So we have 160x plus 800y greater than or equal to 64. And we have 200x plus 200y equal to 40,000. So let's see this example. So now we know 200s plus 200y greater than or equal to 40,000. The second option, we say s should be greater than or equal to 0, and y also should be greater than or equal to 0. So the solution is restricted to quadrant 1, and it accesses that bound quadrant 1. So this is our equation. Second, 160s plus 800y equal to 64,000. This can be graphed with x and y intercept. So first, when x intercept when y is 0, And this is the answer we get, S400. Now, y-intercept means when y is 0, we get 80. I mean, y-intercept means when x is 0. S-intercept means when y is 0, we find the s value. And when s is 0, we find the y value. So this will be the graph, 200s plus 200y equal to 40,000, and 160s plus 800y equal to 64,000. So by looking here, we have some endpoints here, 0 and 200, 150 and 50, 400 and 0. So next, the corner 150 and 50 is found by solving simultaneously as follows. So this value again is equivalent to this. So finding equation 1 minus equation 2 gives one equation in one variable, and also it will allow us to complete the solution. So here we have 4y equal to 200, so y will give me 200 by 4, which is 50. Also s equal to 200 minus y, which will give me 150. So again, that will be the conclusion of our lectures. Again, in these lectures, our goal is to understand the concept of, again, linear inequalities in two variables. As we said earlier, linear inequalities with two variables. Most important thing, the first thing, again, we always, excuse me, the first thing we always have to do, again, is to check the condition. And we have the condition, and then we solve it from there. So as we can see, I have inequality, any value, any expression. So first thing, we know the condition is given. The condition, when I said condition, I met, example here, we graph inequality 4x minus 2y is less than or equal to 6. Less than or equal to 6 is our condition. So the first thing we have to do, we check the condition, then we plot the graph 4x minus 2y equal to 6. When we get the answer finish, take any point. In this case, we are going to get only two regions, the line divided into two. So take any point in one region. If the condition met, when we take a point, we get the value of s and y. When we plug it, we will see the left answer is less than or equal to 6. If it is, then that region is the solution. If it is not, then the other region will be the solution. Again, if you want to check, the other region can take any point, it should satisfy the condition. Now, if it's a system of equation where we have two inequalities, then we have to do the same step, plot the lines for each, then based on the condition, we are going to again have the area or the region where it meets the condition. So again, wish everybody the best and thank you for your time.